Hey guys, so I wanted to do a little bit of reviewing before you guys went through these problems. So what I'm gonna do is eventually I'm gonna do problem 1 and 3 for you, and you guys have videos for 2, 4, 5, 6, and 7. The teacher that is going through the problems for the 2, 4, 5, 6, and 7 is not me. So if you get confused, please send me a message on Teams and I will be happy to record and walk you through any of the other problems that you might have issues on. I want to do number 1 and 3 because they're probably the longest problems on your worksheet. And I figure it would help you out if you could see the whole process from beginning to end. Okay? But first, I'm going to do a little bit of a review. Okay, so we've been talking about heating and cooling curves, right? And we've been talking about what equations to use for each of the sections of your heating and cooling curve. So I am going to pop over to our two curves, which should look very familiar to you, okay? The first one that is in red is going to be your heating curve. And if you guys remember from all of the lessons that we've been learning over the past couple of days, well, end of last week until now, we talked about whether things were endothermic or exothermic, right? So, you know, when you're heating, we're adding heat to the system, right? And that heat is going in to do a bunch of things, right? It's going into heat up the temperature of, we'll use water in this case, because that's what your worksheet is about. So I will walk through the heating curve for you, just so you guys can, you know, remember what it's all about. So when we get to A, right, we are starting to add heat to the system. We add heat to the system and we are in a solid state, okay? And then once we get to B, we're adding heat, but the temperature is not changing because all of that heat is going into breaking all of the bonds in our solid to form a liquid. Okay, then we keep adding temperatures, and now we're into section C. Section C, we are fully a liquid, and as we add heat to the system, that temperature is going to go up. And then once we get to D, okay, we're going to plateau again because all of the heat energy added in that section is going to breaking those bonds in the liquid so that we can fully become a gas. And then in E, we continue to heat while we're a gas. Okay, so that's pretty much what I want you to remember about your heating curve. Now, because of all of this energy that is being absorbed from the environment, a heating curve is considered endothermic. The reason why I'm bringing this up again is because it's going to be reflected in the numbers that you get. So anytime that you're calculating Q, if Q is a heating curve, your number will be positive. Okay? Now let's flip to the cooling curve. So you have the cooling curve in blue, right? Remember that we are starting at a high temperature, and then we are going to cool or remove heat from the system. So as we cool, we go from a gas, and all of this heat is being released, right? Then when we get to D, all of that heat that's being released is going into converting back into a liquid. And then we're removing more heat and we're cooling some more. And that is C. And we are finally back from a gas to a liquid state. And then we get to B and we are going to make that conversion, excuse me, from liquid to ice, right? Removing more heat from the system. So you should realize that a cooling curve is exactly the opposite. It is an exothermic reaction. So in this case, when we're trying to measure the amount of heat, which is always Q, your number for your cooling curve will always be negative. And I'm telling you this because when you're doing these problems, it is a great way to check yourself. Okay, so if you're doing a heating curve and you end up with a negative number, then that means that you did something wrong. Or if you have a cooling curve and you end up with a positive number, that means you did something wrong. Okay, so just use these internal checks to try and make sure that you're on the right track. The other thing that I want to review are going to be your equations for each section. Okay, so if you remember, you have 3 different formulas. Q, the first one up top, Q equals MC delta T. right, is going to be for any time that there is a temperature change in your curve. So for that, that is going to be A, C, and E. Those are all of your diagonal lines. You're always going to use Q equals MC delta T. Okay? For the section which represents freezing or melting, which is section B, you are going to use Q equals the heat of fusion times the number of moles. And then if you take a look, what's at section D is going to be used for vaporizing or condensing. You're going to use Q equals the heat of vaporization times N. Okay? The specific heat is always something that will be given to you. It's not a number that you have to remember. It's just a number that you have to recognize. Same thing with the molar heat of fusion. Okay? For the most part, it is either going to be given to you in the problem, or it will be hinted at in some way just so you know how to calculate the answer. And of course, what goes for the heat of fusion goes for heat of vaporization. Okay? Now, the other thing I want to point out are going to be the units. So because we are going to be trying to find the total number of heat in a particular system, that means that we're going to be adding up all of our Q values that we get. The problem is going to happen is our specific heat, our Q value will be in joules. Okay? I'm sure some of you guys can point out the issue for me. Your molar heat of fusion, guess what, is going to be in kilojoules. And so is your molar heat of vaporization is going to be in kilojoules. So that means if we are going to need to add up all these different Q values from all the different sections, that means we need to make sure that we are in the same unit so that we can add them all up together. Okay? So that is the basic of what we need to know for the review. Okay, so hopefully that was helpful. The next videos, I'll be recording the stepwise procedure to get through some of these problems.